Hello everyone and welcome back to another video. In this video I'll be going over continuing section 3.6 with a focus on Simpsons Rule. So before we get into what's the whole formulation of Simpsons Rule and the example, I just briefly wanted to talk about what it's really doing. And so right, this is the textbook here, and if we look at these images, what's going on is that we're basically using polynomials to estimate the area under the curve, right? So if we take a look at this image, right, the first polynomial goes from x0 to x2. So this is basically like a zoomed in image of this image on the right, and so then that first polynomial estimates that part of the curve, and then the second one estimates this part of the curve. So we're basically summing up the area under a bunch of tiny little polynomials. And so what Simpsons Rule says, right, Simpsons Rule is assume that f of x is continuous over a comma b. Let n be a positive even, caps locking that because that's important, integer. And again, the width of the subintervals, we're still using the same formula, b minus a over n. Let a comma b be divided into n subintervals, each of length delta x with endpoints at p equals x naught, x1, x2, so on and so forth, up until our very last one, which ends at n. Then Sn is equals to the change in x over 3 times f of x0, and this is important, right? The first one does not have a coefficient. The second one's coefficient is 4, and then the next one's coefficient is 2, and the next one is, so it alternates between 4 and 2 and 4 and 2 and 4 and 2, right? And then let's say we make our way all the way downtown. So in the end, you're gonna have 2 for the third to last, and then 4 for the second to last, and then the last one has absolutely nothing, just like in the trapezoid rule, right? And then again, for all of these, the more that we break up the intervals, the merrier, because we shrink the error, right, as I showed in one of those very early videos. So the limit of Simpsons Rule is also equal to the definite integral. And note that Simpsons Rule is actually also a weighted average. Simpsons Rule is a weighted average of the midpoint rule and the trapezoid rule. And this formula for Simpsons Rule shows us that where you do 2/3 times the midpoint rule for half of the intervals that you want to do Simpsons rule for, plus 1/3 times, again, half of the intervals you want to do Simpsons rule for the trapezoid rule. So, right, these two formulas both work for Simpsons rule. Which one you use depends on the information you have at hand, right? So if you already calculated the midpoint and the trapezoid rule for n/2, then that's an easier formula. If not, just go with this one. So let's do an example. So use S2 to approximate the integral from 0 to 1 of x cubed dx. So n here is equals to 2, right? That's the number of subintervals. So then the change in x is going to be 1 minus 0 over 2 is 1/2. So that makes our subintervals, right? We start at 0, go over 1/2, go from 1/2 over to 1. And those are our two subintervals. And so then Simpsons rule, S2, right? Remember that out here we have this change in x over 3. So we have 1/2 over 3. And then we have, remember, it's the first one has no coefficient, and then it starts with 4. So the second one has 4 as a coefficient, and then the last one doesn't have any coefficient, right? So we only have 3 distinct endpoints here. And so then, right, this becomes 1/2 times 1/3, right? I just pulled down the 1/2 here. And then f of 0, remember f of x is x cubed, so that's just 0 cubed, plus 4 times 1/2 cubed, plug in 1/2 into x cubed, and then lastly we have 1 cubed. So this just becomes 1/6, and then this is just 0, and this is just 1. So then 1/2 cubes, that's 1/2 times 1/2 is 1/4 times 1/2 is 1/8. So that's 4 times 1/8 plus 1. Right, so that's just 4/8 plus 1. Right, so then that's going to become, remember 1 is 8/8, so that'll just become 12/8. And so then we multiply across, so 1 times 12 is 12, 6 times 8 is 48. And we can simplify that, right? We can divide the top and the bottom by 12, and that would be 1/4 as our answer. All right, thank you.